So okay. So we will begin. You don't worry. I'm sure they will answer like the call or the message very soon. But I will just do my lecture and then maybe you have a note, just like how you sit in a what do you call it, the lecture hall. Try and do same. I know most of you are at home and you often take this lectures informally, but I would advise that if you have a notebook or something, you keep it beside you so that you can walk through the various things we are doing, okay? Because I try to be as practical as possible with you, okay? Okay, so let me just go to the slide and then, okay, so everybody can see my slide, right? Hello, can you all see my slide?
Yes, sir.
Okay.
Yes, sir.
That's good. So today we are going to run till a little late in the evening because I learned that your lecture should end around somewhere like 8:30. Okay, so we are going to run till a little later. Okay, but we're going to do. I'm going to give room for more questions on your part so that you can ask me any questions. Okay, so please, like I said, take notes. Have your pens out so that you can do a little bit of yes, note taking as well. Okay. Okay, so we are going to start by looking at variables and memory. Okay, so last week we learned what programming is. We learned about programming paradigms, various styles of programming. We learned about the advantages, where computers came from, and why programming is important. The fundamental reasons why programming and computer hardware go together. Okay. And now we are going to delve deeper into programming. But before we can understand programming proper, we need to be able to understand the concept of programming variables or variables and variables how variables are in memory. Okay. So we will first look at what a variable is, and then I'll try and explain some of the various properties that are commonly found in most variables. Remember, here we have not spoken about a specific programming language, but I think as part of your course, C++ is industry standard. And so I'm going to make mention of C++ often. But before C++, I'll mention about pseudocode so that you can at least relate it a little bit to something very practical. Then we'll delve a little bit deeper, okay? So we'll talk about programming variable properties. We'll talk about memory and how variables are represented in memory and how your program is represented in memory. And then we'll talk about how to do what we call variable assignment, how to put values inside variables. We'll also talk about the best practices for variable naming. Now, what I want us to do is that I will do the entire session, and then at the end of the session, I will make room for you to ask questions. But during the session, if you have any questions, you kindly share it in the chat. Okay, I'll be looking at the chat occasionally from time to time so that I can answer your questions as best as I can. Okay, if your question demands that I take my time and then explain, I'll reserve it to the end of the session and then answer your questions thoroughly. Okay, are we okay with that? But at the end of the session, if you also want to ask a question, you are free to raise your hand and ask a question in person, okay? So that we can all get a good understanding of the course that we are doing, okay? So let's quickly look at what a variable is and how we can make use of them in programming, or how we make use of them in programming. Okay. So when we say, or when we talk about a variable, we are talking about a placeholder. Okay. A variable is something like a placeholder. When we say a placeholder, remember when you go to the tap or you go to the pipe, like we call it, and you want to fetch water, you don't open the faucet or the pipe and then the water will come out and then the water will fly into your mouth. But you need something like a cup. You need a cup to collect the water from the pipe and then send it to your mouth and then drink it. Okay? Or you need a bottle to hold the water. Or you need a bowl. When you are collecting food, you need a bowl to hold the food. If it is rice, you need a plate. If it is soup, you need a bowl. So you notice that even with food and with water and with all these different kinds of things, there's a particular container we use to hold the specific thing that we want to hold. Okay. So in programming, that idea about a container is what we call a variable. Simply put, a variable is a container. Okay. We use variables to hold values we will use during the program execution. When we say program execution, we are simply talking about when the program starts to run or when the program is running. What do the data we will manage, or the data that we will use in the program, how would we hold that data so that we can use it? Okay, so a variable is a container, just like the cup, just like the bottle, just like the plate, or just like the bowl. Okay, so a variable helps us to hold data when we are running the program. So you notice that even for those items I mentioned, like water, we cannot use a plate to hold water. We need a cup, or we need a bottle, or depending on the amount of water, we need okay. So it is important to understand that a variable is a container. That container will hold a type of value during the program execution. Now, the cool thing about programming is that unlike food, which maybe if you put rice inside the plate, you will eat the rice. Okay, the rice will not change into banku. But in programming, when we run the program, the variable, the thing we put inside that container can change. Okay, can change. For example, when most of you, I know most of you have Facebook accounts or Instagram accounts. Now, when you launch your Instagram account on your phone or on your laptop, it will first ask you for username and password. Okay, where you enter maybe your phone number as username, or you enter maybe your email as your username, and then you enter a particular password. Okay, so notice that those two empty boxes are examples of variables, or how programs use variables. Now, some of you have like 2 or 3 accounts. Okay, some of you, I know, you have maybe a business account, you have one that you use to chat with your friends, and then you have one that you use to do business. Okay, so when you enter maybe your business account, in the future, or when you are checking your messages, you can decide that I no longer want to log into my business account, but I want to go into my personal account. And then you, at this point, change or log out of your business account and come and log into your personal account. Okay, so that's what we mean by variables are dynamic. They can change. When you create those two containers, whenever the user feels like they want to change what is inside, they can change what is inside. Okay, so variables, in actual fact, are these kinds of things. They hold a quantity which can change during the execution of the program. So I gave some examples like my name, my number, name, amount, maybe price, fixed price, principal, rate. All of the name of the variable usually describes what the variable represents. Okay, or you can simply use X, Y, Z, and any of those single arbitrary letters. Okay, now technically, like I said earlier, a variable refers to a storage location. Okay, so the two places or the two empty boxes, username and password, they are empty boxes. Now, when you type, maybe my username is Bernard at yahoo.com. When I type Bernard at yahoo.com, Bernard at yahoo.com will be placed inside that particular username box or that username variable. Then maybe the password is 1234 star. 1234 star will now be collected from the keyboard and be placed inside the password box. Okay, so that is what a variable is. A variable will give a name to a particular memory location. Now, that empty box is not just an arbitrary box, it is a memory location. Okay, memory location, very, very important. Okay, now variables have properties. Okay, variables have properties which will help us to relate with them or understand what is either variable. Okay, number one is that every variable has a name. Okay, the name is like the title. So my name is Bernard. So if I didn't have a name, how would you call me? Okay, you wouldn't be able to call me, or we wouldn't be able to even call yourself. So every variable must also have a name. Now we'll come and talk about the name later on, but there are rules in programming for giving variables names. For example, if you go to maybe Gan culture, there are rules for naming children or naming twins or naming men or naming women in Gan. Or if you go to maybe Akan culture, there are rules for naming. So is it better? Hello?
No.
Are
It
you the
isn't
only
better.
person or everyone? Everyone? Is it for everyone?
Everyone, it's Blair.
Wow. Okay, then I think it's the internet. It's not really. As for the Blair, I do not know where it's from, but I think it's the internet. Okay, I'm using a Vodafone router, so I think it's occasionally going
I
down.
think it's because your video is on, so maybe you can turn off your video first.
Okay. Yes. Let me conserve the speed and then turn off the video. Okay. Is it better now?
Let's give it a minute and see.
Okay. Okay, so whilst we wait for it, I'm just mentioning, but you can hear me, right? You can hear me, right?
Yes.
Okay. So, like I said, every variable requires a name, but based on a particular or the particular programming language, we might have different rules for naming. Okay, so think of the programming languages like the culture that the variable comes from. Okay, so if you maybe learn C++, there will be rules on how to give variable names in C++. If you learn maybe Java, there will be rules on how to give Java names. Okay, but the name is one of the most important things in Java. In programming or in creating variables. Okay, the next most important thing is something called the data type. Okay, so like I said earlier, if you are given banku, you know exactly that, oh, bring a plate. Okay, if you are given banku with soup, you know, oh, bring a bowl. If you are given maybe rice, bring maybe a plate. Okay. Okay, so depending on the food, you know exactly what type of instrument you are going to use to eat the food. It is the same with variables. Okay, variables also have types because we have different type of data. Even to us, my name is made up of characters. Okay, Bernard, characters. My age is a number. Okay, maybe my how do you call it? Maybe my bank account balance. It's even though that one is also a number, but it's a decimal number. It's different from my age. So you notice that there are different types of data, right? Every data, there's actually a different type of data. Okay. And that is what we term as the data type. The data type represents the kind of data that is stored or put inside the variable. Okay, so that one too is very important. We'll come and talk about data types very, very, very soon. And the next most important thing is the value of the variable, what we are actually putting inside. So when we say that this variable can store names, the name we are actually putting inside, is it Bernard or is it Bachman or is it Akosia or is it Apona or is it Achua, or what the thing we are putting inside is the value of the variable. Okay, then we have something called a property called the scope. The scope of the variable tells us where we can see the variable. Usually when we're writing programming, depending on the paradigm, we can sometimes see the variable in different places. Okay, so usually where we create the variable or where we inherit the variable. Okay, so sometimes we have this we call global scope variables and local scope variables. What it means is that sometimes the variable can be used throughout the program. When I create a variable maybe called name, everywhere I am within the program, I can see the variable name and the value that is in the variable. But sometimes too, I can create a variable in such a way that even though the variable is created within the program, I can only see that variable and its value in a specific place within the program. That is what we call the scope of the variable. And then the lifetime refers to the duration in which the variable exists. Some of the variables, once you run the program, it will exist until the end of the program, when the program is destroyed or is ended. Some variables, to when you even end the program, it will persist. It will stay in memory till the next time that the program is run. Okay. Then there are others to which when we run the program, it will be created, the variable will be created, and during the lifetime of the program, even though the program has not ended, that variable and its value are destroyed and the memory in it is wiped. Okay, so that one is also a very important property. Thankfully, you as a programmer who is learning programming don't need to really concern yourself so much about that one. Okay, then the next one, which is also equally important, which you don't also need to concern yourself too much, is the memory, the location of the variable in memory, right? Unless maybe you are doing pointers or maybe struts, you don't even need to concern yourself with where the variable can be found in memory. We can actually get the location, okay, using something called pointers, but for the programming language. That's the name, the data type, and the scope are very important. You must understand it as a programmer or as someone learning programming. Are we okay? Can you see the screen better now?
It's still persistent.
Yeah, it's still like it
So
is.
I think it's the network. It's the network. It's
Yeah.
the network. Why? It's
But
if I
it's
turn
clear
it
at
off,
my end.
I'll pardon.
It's clear at my end.
Okay, it's the network. I'm so sorry. Okay, I'm using Vodafone, so I don't know. I think sometimes it just goes down and comes back on. Yeah. Okay, so let's continue with the the properties, and now talk about how variables store some of the key things or issues we term or we that what are important to us when we are creating variables. One of the key issues which is important is memory and how we store variables in memory. Okay, it's essential. In order to write very good programs, you need to write the program in such a way that the variable is stored efficiently. When it needs to be created, it's created. When it needs to be destroyed, it is destroyed. Okay. Now, each variable. Okay. Oh, you can't hear. Oh, can't you all hear me? It's not raining here though. I think it's because of the rain.
I can hear you.
We can hear
Yeah.
you.
So the gentleman complained about the rain. I think it's because of the rain at your end. Okay. It's not for me. Okay. I'm so sorry about that. Okay. Okay. So someone is advising you to use headphones. Okay. Okay. So so variables need to be stored in memory. Okay. So just like most of us have been to a library before. Okay. Have we been to a library before? Right. Oh, Mr. Mohammed Osman. Yeah, I understand your concern, but I'm currently in the middle of teaching the class. If I drop out, it will be some way. So you let me teach the class. Just follow. It will clear up very soon. Okay, Mr. Mohammed. Okay. So if you go to a library, okay, you notice that there are so many books in the library. Okay, there are so many books, and the books are usually arranged on shelves, which themselves are numbered. Okay, the shelves are numbered. Or ideally, if you go to any community, the houses have a house number so that we can locate particular houses, and that is how the computer organizes variables in memory. Okay, so the books in memory have a particular location. So maybe shelf A, maybe shelf A, line 1, so that you can know exactly where a particular book can be found. Okay, and that is the same idea with the street numbers and the same idea with the memory. Okay, so memory has addresses, and what happens is that when you create a variable, particular sets of addresses are assigned to the variable. What it also means is that depending on the size of the data, some number of memory cells are used. Okay, so that is what we mean by storing the variable. So for example, a decimal number, you see a decimal number has two parts: the whole number part, then the decimal point, and then the number after the decimal point. It will use more memory than a whole number. For example, if I have the number 10 and I have the number 10.0, notice that 10 will use less memory than 10.0. Okay, because 10.0 has two parts. I need to store all of those two parts in memory, whilst 10 has only one part, the whole number part. I need to store only that whole number part in memory. Okay, so that is what we mean by storing of the variables. Then another important thing is the data types and memory. Now, like I said earlier, when you create a variable, you usually create it because you are storing data of a particular type. Okay, you are storing data of a particular kind of data. Now, what the data type helps us to do is that it helps us to determine the size or the type or the kind of information going into the variable. Now, in programming, there are usually about three different classes, okay, or majority, there are two different classes of data types. We have something called primitive types, and we have something called complex or reference types. Now, with the primitive types, we have types like what? Integer, whole numbers, right? All the whole numbers, we call them integer in program. Okay, we have characters, single characters like A, B, E, C, full stop, question mark. Those things are called characters. Okay. Then Boolean. Boolean is true or false. Anytime we have data which is supposed to be true or false, we call it Boolean. Okay. Then float. Float is data which is what? Decimals. Okay. In programming, we don't call it decimal, we call it float. Okay. Then we have other types which are more complex, which are made up of combining those basic. When you combine the basic type, you get what we call complex or reference type. So we have something called array, we have something called a list, string, class, or a struct, or an object. Those things are called complex types. So they tell the computer how much memory to leave for a particular type of information. Okay. Then with regards to creating variables, the computer program needs to have a way of managing memory. When we say managing memory, what it means is that when we create a variable, there needs to be a way of assigning empty spaces to that variable. When we put something inside that variable, the program needs to find a way of putting a value into those memory locations. Now, when we finish using or changing the variable and we are done with the program, we need to find a way of destroying the variable or getting rid of all the data and the variable values. Okay, so that one is mostly managed by the computer program. For example, C++ compiler or the particular interpreter that you are using. Okay, is it understood? Is what I'm explaining understood? Okay. Okay. But if you have a question, kindly bring it up. Okay, like I said, today we're running till very late, so you can bring it up and then we can answer the question for you. Now,
Please,
we don't just okay, Mr. Osman. Yes.
Okay, sir. Please, the complex, you didn't explain the array, the string, the list, and the struct. You didn't explain that one.
Oh, how I just explained it. I just mentioned that when we combine the basic types, we get complex. Okay, when we combine the basic types, yes.
No, you explain the integer, the character.
Yes, okay, there's a session on the data types. Okay, so let's do it at a session of the data types. Okay.
Yes,
Hello?
please. I'm here. I'm here, sir.
Okay. Yeah, so there's a session on data types, which I'll take my time and explain them. Okay. So
Okay. The screen is okay.
please, sir, I couldn't join earlier. In fact, the variable, the term variable,
hello.
I wish you could throw small light on it.
Hello. Hello.
Hello.
I can't hear you.
Hello, sir.
Yes. Yes. What did you say?
Hello, sir.
Yes, I can hear you now. What did you say?
I was saying that I
I
didn't
can
join
hear you
early.
now. What did you say?
I'm saying that I didn't join early, and I wish you could throw small light on the term variable for me.
Oh, a variable is a container. Okay. So a variable is a container. We will put something inside when we are doing the program. Okay. For example, your Facebook, you have a username and password. Okay. Maybe you have 2 Facebook accounts. So a variable is a container that will hold your username, and there will be another container to hold the password. So that when you are browsing your Facebook and you are tired of maybe browsing one account, you can log out and come and change the username and password and then log back into another account. That's what a variable is. And that's what we are trying to explain, how a variable is stored in memory, some of the major issues about variables.
Okay, so it's like the button that appears when you want to type the password.
No, it's not a button. It's not a button. Listen to me. I said container. I didn't say button.
Oh,
Don't put words in my mouth. I said container. I didn't say button.
All right, sir.
I never mentioned button. I said container. Okay.
All right, sir.
So just like it's just like you going to fetch water. Okay. You don't just go to the pipe and then just turn the tap on, right? You go with a bucket. Okay. Right.
All right, sir.
Hello. You go with the bucket. Yes. So the bucket is the container. Right?
Okay. All right.
I'm sure if you are going to collect food, okay, you don't go with a bucket, but you go with a plate or a bowl.
Plate. Yes, sir. Yes, sir.
So there's a container for a specific kind of activity or action. And that is what a variable is.
Oh, okay. All right.
A variable is this time around in programming, you, the programmer, you will create a particular type of variable. Either you are creating the bucket or the plate or something. It's a container. So it will hold some information which you will use during the program. Right? Depending on what you are going to do, you will either create a big variable or a small variable. Okay.
All right, sir. It's clearer.
Yeah. So that's what it is.
Thank you, sir.
Okay? You're welcome. Okay. So variables need the data. You need to put the data into the variable. In programming, we call that variable initialization. Okay, initialization is when you put the data into the variable. When you create the variable, you just tell the computer that, hey, I'm creating maybe an integer variable, or I'm creating maybe a float variable. I did mention that float also means decimal. Okay, we say decimal, but in programming we say float. Okay, so please take note of that. Or I'm creating a string variable. String represents when you put characters together. Okay, for example, my name. My name is made up of several characters, B-E-R-N-A-R-D. So you see, when you combine characters, single characters into one word, we call it a string. Okay, I can also put a sentence. I am a boy. I am a boy is a string. Okay, so something like that, we call it string. Now, when you create a container to hold a string, right, we call that variable declaration. Okay, then when I want to store maybe true or false value, I'll create something called a Boolean variable. So an example is what you see over there, the bool, B-O-O-L, and then the variable name is called answer. Like I said, the name of a variable is very important. Okay, so the name always comes after the type of variable. So we have integer variable called x, a decimal variable called y, a string variable called f, name, and then a Boolean variable called answer. Okay, remember Boolean, I said Boolean stands for what? True or false. Now, when you want to put something into the variable in programming, we use the equal to. Okay, the equal to is used to mean assignment. In programming, equal to means assignment. Equal to does not mean equal to. Okay, please take note of that. So in most of the programming languages, or in all of the programming languages, when you use one equal to, what it means is that put something inside another thing, right? That's what we call initialization, okay, or variable assignment. Like put 2 inside. Maybe you can see the examples on the down here where I'm showing you that I'm putting 10 inside x, and x is an integer variable. The reason why I'm putting 10 inside is that since we say that x is an integer means whole number, you cannot put a decimal inside. You cannot put anything with a decimal point inside. Okay, that is the rule. That's the rules. Just yes, sir. Did you put up your hand? Kindly put up your hand and then mute and then wait for us. Okay, let me finish explaining, then I'll give room for asking questions. Okay, did you hear me, Mr. Richard? Mute. Okay, thank you very much. So why is a special container for holding decimals. So you see float y, and then we want to put the number 8.0 inside y. So you write y equal 8.0. So this is how to put 8.0 inside y. Then the next one, you see string f name equal quote 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 ben quote. Okay, so what it means is that I'm putting the word ben, which stands for Ben, inside the variable called f name. Okay, f name is just maybe myself. I'm creating a variable for first name. Okay, the short for first name. Or in some programming languages, you can create the variable and then later on put something into the variable. For example, when I'm creating a variable, I don't know that I want to put the number 10. So I create a variable int x. So the variable is being created. Now, after creating int x, later on in the program, I now put 10 inside x. Okay, so that one can also be done. It is very possible to do something like that as well. Okay, variables can be initialized. In fact, variables must be initialized before you use them. Before you say, hey, computer, add this to that or give me this, you have to put something inside. The computer cannot imaginatively or out of thin air produce any value for you. You have to put something inside the variable you create. Okay, Mr. Richard, is there a question? Mr. Richard? Okay, I think he's off. Let's go to another slide. Okay, now, so I have examples, other examples over here to show you as well. So in this example, I am showing you that you can perform some basic operations. So here we create two variables. The first one, we create two variables, variable called num1 and a variable called num2. But notice that num1 equal 10, num2 equal 5. What it means is that put 10 inside num1 and put 5 inside num2. Now, the both of them, num1 and num2, are all integers. That's why I only wrote int once, and I separated the two of them with comma. Okay, so when you do that in programming, it tells the computer that, hey, num1 and num2 are both integers, but num1 is equal to 10 and num2 is equal to what? 5. Now I've created a third variable called sum, S-U-M. And S-U-M is equal to num1 plus num2. So what does it do? It will ask the computer to now add what is in num1 plus what is in num2 and put the answer inside SUM. Now, this is the main purpose of a variable. The purpose of a variable is to hold a particular value so that we can use the value without the actual numbers. We don't want to use the 10 plus 5, but instead, we want to use the containers so that in the future, if we want to change 10 to maybe 50, we don't have to come back into the program and come and change the 10 to 50, but we will just change what is in num1. Do you understand the idea? The idea is that use containers because containers contain something so that in the future, if you want to change what you are doing, you simply change what is inside the container and then you can do the same thing or you can do a different thing again. I hope you understand. So that is the practical demonstration of what a variable can do or should do. Then the second one, like second example, I'm showing you an example in Python. So in Python is a programming language, okay? So Python is a programming language, and here what it's doing is that I'm collecting something from the user. So I'm collecting the name and putting it inside a variable called name, okay, or N-A-M-E, okay? So input is a function, okay, something called a function. We'll talk about that one later on. Then the next line is how to do the same thing, okay, something similar in C++. Okay, C++ is also a programming language. So cin is a function which will let C++ collect something from the keyboard. Okay. Then I'm showing you the next example, how to collect the same thing or something similar in Java. Okay, so in Java, I'm collecting a line, or what you type on the keyboard. I'm collecting everything. Once you hit enter, everything will be collected and put inside the variable called month. Okay, then in pseudocode is not a programming language, it's just plain English, but it's written in programming logic. Okay, I'm writing or collecting something from the keyboard from the user and putting it inside a variable called amount. I hope this is explainable, right? I hope most of you are following me. Okay.
Yes, sir.
Hello,
Yes,
sir.
sir.
So, sir, please. So when you create a variable called integers,
No, the
those
variable
data
cannot be called integer. Hello. The integer is the type.
is the type. Okay.
Yes, like I said, you have banku, fufu, and those things. Okay. So when you are going to collect banku, you go with maybe a plate, if it is maybe pepper or stew, right? But you go with a bowl if it is what? Soup. Okay, so the int is the type. It will tell the computer the type of memory or the size of memory to apportion for your data. You can go on.
So I'm a bit confused here. With the integer, right? You can
Yes.
only enter in the integer data, right? Integer data. So
Yes.
you will have to create, maybe when it is float, you have to create
Yes.
another one for float.
Yes. Because
Right.
it's unlike you. You see, you are a human being. You can think and reason, but the computer is not a human being. It cannot think and reason, unlike you. Okay, so that everything you want your program to do, you must think about it first and do it. That's how it works. That's how programming is done. You must think about it. You must create the variable. So if you want to do decimals, you must create float variables. If you want to do integer, you must create integer variables. If you do not create float variables, it means everything you do will be integer. You will not see any decimals. You only see whole number, whole number, whole number, whole number. You understand me?
Sir.
Yes. So very important. Mr. Clifford.
So I just wanted to give an example to what he said. Like maybe I want to create a variable to store someone's name, age.
Yeah.
So
Yes.
the name of the variable could be age. But what is the age?
Hold on. You said what? Are you storing
like,
the name or the age?
I'm creating
Which
a
one are you
variable
storing?
to store the age of someone.
Okay.
So the name of that variable, I could give the name of that variable as age.
Thank you.
But what type of data am I storing? Age. Is the age a float? Is it an integer?
No. I'm sure you are not maybe 20.5 years old, but you are 20 years.
So it's an integer.
Yes. Thank
so
you. It's
that
a
the
whole
data
number.
type will now be integer, not the variable that will be the integer. The variable will be
The variable name will be age.
age,
the type
but
will
I'll
be
define that any value that will be put there should be an integer.
Yes.
Which will be the data type.
Yes. Thank you very much. Okay. So the variable data type is very important. You, the programmer, you must master the ability to know the type of information, because the computers will never do it for you. Okay. They cannot tell the type of data. You must tell the type of data. So for example, if you are storing your name is a string. If you are storing age is a whole number, integer. If you are storing the price of something, because there can be coins, okay? Because there can be coins, it will become what? A decimal, float. If you are storing true or false, okay, the answer to questions, true or false, That will be what? Boolean. Okay. So please, there's a hand up. There was a hand up. Hello, there was a hand up. Someone put their hand up. Have I answered your question?
Hello, sir.
Yes, I can hear you.
Sir, please, I was actually having a question, and I wanted to know on this particular slide. Please,
Okay.
are you making a declaration statement in this programming languages, or is just representing variables?
I do not understand you. What do you mean?
Sir, for
I'm
instance,
showing
let's
you
say
variable assignment. I was showing you
assignment.
variable,
Okay.
how to put values into variables.
Oh, okay.
So I
Because
don't know, maybe, and I'm showing you how to do it in different programming languages.
oh, okay, sir. Because I was
That's the
thinking
example you see down there.
Oh, okay, sir. But some of the statements in writing a variable, they start the statement with the variable is a var before adding the, the variable name.
That one is I think it's JavaScript. I don't have it as an example here. That's why it's not here. The ones I have here, I put the type of programming language there.
Oh, okay, sir. It's clear, sir.
Yeah. So it's better if we could see. Okay. So now, what are some of the best practices? When we say best practices, when you are creating variables, what should you do? You see, every programming language has its rules for creating variables. So we cannot use a particular programming language's rules, but there are some things that will run common. Okay, that will be common in all of the programming languages. Okay, so I've listed a few of them. A few of them are also in the PDF, and then I should think we can throw a PDF here, right? Okay, let's see. Okay, you let me. Okay, so let me run through them, and then I'll get back to that one later on. Okay, so number one is that use descriptive, intention revealing names that will explain the purpose without comments. What they simply mean is that, like the gentleman gave the example about the variable he wants to use to hold the age. So that variable must be called age, so that when he comes and he sees the variable, he knows what is inside the variable. Okay. If you want to create a variable to hold the name, the first name, or the middle name, or the last name, or maybe you want to create a variable to hold the username or the password, name the variable with the thing you want to do, instead of using something like X, Y, A. Some people name the variable with one letter. Okay, when you come back in the future, you will not remember what the variable must do or should do. Okay, so kindly remember that it's very important that you name the variable with a descriptive name. Okay. Next, number two is that use some naming conventions. So in programming, sometimes variable names, the purpose or the description can be more than one word. Okay, but in programming, most programming languages don't allow you to use more than one word for naming. In fact, all the programming languages, you can only use one word. So we can use one of these various ideas to combine the word. Number one, we call it something camel case. Camel case means that you make the first letter or the first word a lowercase, and then the second word will be capital letter. Okay, so for example, I want to store first name. I shouldn't write first space name. Instead, if I want to write a variable name, then I must write first name all as one word. But how do I distinguish between the first and the second? I simply use capital N in the middle. So you see that between the first and the name, there's no space. Do you see that? Then another example, ST. ST is for students. Okay, so sometimes we can use shorthand of different things. But you see, the ST is all lowercase, and then the number is what? Capital N. Okay. Then we have ACC, account balance. So you see, ACC is lowercase, then balance, the B is capital letter. Okay, so when you do something like this, we call it camel case. It's just like how the camel, you see the camel from the front to the place where there's a haunch. The camel is all lowercase, and then the haunch is the uppercase, and then the back of the camel is all lowercase again. So that's how it looks like. That's why we call it camel case. Then we have something called snake case. Snake case means you can use lowercase, capital, lowercase, capital, like that. Okay. Then you can put underscore. So this one is still one word, but there's no space. Okay. Instead of space, there's a character called underscore. Underscore is an acceptable character in programming. Okay. So you see, first underscore name, then student underscore number, then account underscore balance. So you see, it's like a snake. It coils back and forth, down and up. Okay. Then if the variable contains true or false, sometimes we can use, we can prefix the name with is or has. Okay. So an example is active, is visible, has answer. Those type of things. Immediately you read the name, it tells you that that variable contains true or false. Okay. Then constant, we normally write constants in uppercase, all uppercase. So an example is pi. Okay, you know that everybody remembers what pi is, right? The pi represents what? The half of the diameter of the earth. Okay, so something like that. You write all of that in capital case. Okay. Then another important thing I need to mention is avoid using something called reserved keywords or special characters. In programming, there are some characters which are reserved for the programming language, like backslash. Don't use backslash in the name. Okay. I think you can only use underscore and $sign in most programming languages. So you only use those ones. Don't use space. Don't use comma. Don't use quotes. Don't use any of the other characters on your keyboard aside the letters, uppercase, lowercase, and then the underscore, and sometimes the $sign. Sometimes the $sign. Then when we say reserved words, those are the words used by the programming language to issue the instructions. So an example is what? Print. An example is input. Don't go and name your variable int. See, so I was telling the gentleman that int is not the name of the variable. Int is the data type. So you can't create a variable called int. You write a variable name called int equal 5. No. Int is already used by the programming language. So you can't use it to name the things you are creating. You can't use float. You can't use bool. You can't use certain words. Those words are called reserved words. When you are learning a particular programming language, there will be a table of all the words within the programming language, the things that you cannot use to name your variables. Okay, so those ones are called the reserved words. And then another hint is that be consistent. Okay, be consistent. Okay, so if you are using camel case, use camel case. If you are using snake case, use snake case. Don't be using camel case here, snake case here, this one here, this one there. No, be consistent. Okay. Another important information is that be mindful of the length, because we said that you can write a name and use underscore or combine them with camel case. You write a very long name. Okay. You write a name like the diameter of the earth is stored in this number. No, come on. You should not have a name that long. Okay, so the name should be simple, diameter of earth, or something simpler, maybe earth. or something. Okay, so please have these are tips for helping. Okay, so I'll take a question or two. There was a question on the chat. It says, I think a strings can hold letters. Yes, strings can hold anything. Once you put it in quotes, it's called a string. I'll come and talk about data types when we get to data types. Okay, but once you put something in quotes, it becomes a string. Yeah. Any question about the basic variables and variable information we just learned? Any question about that before we go to properties and data types? Any questions? Okay. If there's no question, then we jump over to the basic data types and the properties and behavior of these types. Okay. So in programming, variables must have a type. It is very important. Programming languages, all programming languages, in fact, every variable has a particular type, whether they state it or not. Because unlike human beings who can think about the type of information, programming languages cannot do that. We, the programmers, must think for the computer, okay, with regards to what we are creating, because the computer doesn't know what you are creating specifically. You have to tell the computer what you are creating. So you must tell the computer the kind of data you want to put into that container. Okay. There are at least 2 or 3 main types of data types. Okay. We have a type called primitives, okay, or primitive data types. Then we have the composite or the reference data types. Then the user, in some programming languages, there are user-defined types. You not often see that type. You not often see it because it's not in every programming language, okay? But you often see that there are 2 types, reference and then primitive types, okay? When we say primitives, we are talking about the basic data. When you strip everything, what is there? So when you strip everything from the data, it can be an integer, okay? We call it int in programming. Or it can be a decimal. We call it float, or in some programming language, we call it what? Double. When you hear float or double, it's the same thing, okay? It's almost the same thing, okay? Then we have single characters. We call it, in programming, we call it char, right? Or char, okay? Depending on where or how you pronounce it. Then we have Boolean. Boolean stands for true or false values. Okay, so those ones are the primitive data types, the basic types. When you remove all and you look at the basic, you find those ones there. Then when you begin to combine the basic, for example, when I'm going to the market, I will not be creating one variable for every food item. Okay, you understand? When I'm going to buy, maybe I'm going to buy maybe 15 items. I need to create 15 variables, one for each item. No. Instead, I create an array or a list of strings. So we call that an array. Array is made up of what? A combination of those basic data types. So you can have an array of integers, you can have an array of strings, you can have an array of different types of information. Then we have strings. Strings is when you put characters together. Remember, character or char or char is a single character. But my name is made up of about 6 characters. If you combine those 6 characters, it is no longer a single character. It's a string. Okay, so string is also a reference or a composite type. Then we have something like structs. We have different kinds of. We have stacks. We have queues. We have all those different kinds of reference types. Then in some programming languages, usually in the object-oriented programming language types, we have something called user-defined types. The user, you can also create your own data types. Okay, so usually we have classes or objects, and then we have something called enums and so many other things. Okay, so let's jump right in and try and understand. Now, the basic data types, like I mentioned earlier, we have Boolean, we have char or char, we have integer, we have float and double. Okay, now we can differentiate them based on the size of memory. Usually in C++, you normally find that Boolean is 1 byte. 1 byte is 4 bits. Okay, at this point, I think most of you understand what a byte is. Okay, you should understand what a byte is. Okay, a byte is 4 bits. Okay, so in Boolean, if you want to store true or false, you just need 4 bits. Okay, then character or char also stores 4 bits. Okay, then sorry, 4 bits for that's 1 byte. Then integer, you need 4 bytes. 4 bytes, that's 4 times 4, so you need 16 bits to store one integer, right? One whole number. There should be no decimal point in the integer. Okay. Then float is when you have a small decimal number. Okay, usually about 6 to 7 decimal points. You have 4 bytes. Okay, but when you go beyond 4 bytes, we have something called a double. Double, you require about 8 bytes of memory. Okay, Mr. Clifford.
Sir, I was taught that 8 bits makes a byte, and I'm hearing 4
Yes.
bits making a byte, so I'm
Oh,
confused.
sorry. Thank you very much. Thank you very much. 4 bits. 8 bytes. Sorry, 8 bits. Sorry. Thank you.
Thank you, sir.
Yes, it's just maybe my mind was running faster than my mouth. Thank you. Okay. So let me do the correction. 8 bits make a byte. Okay. So over the Boolean, we have what? 8 bits in 1 byte. The char, we have 8 bits in 1. Then the int, we have 4 bytes. So 4 by 8. And then in the float, we have 4 by 8. And then the double, we have 8 by 8. Okay. So that's the number or the amount of memory used by each of this according to C++. Okay, this table is from C++. Okay, it will look quite different if you go to another programming language. Okay. Okay. Now let's go to more examples. So in the next slide, I am showing you some more examples of variable assignment. So we learned that the basic types are integer, a character, a Boolean, a float, or double. So I did some examples of creating those variables and putting something inside. Okay, so it's the first example is a variable called my_num. Okay, and notice that my_num is one word. Please, I cannot stress it enough. When we are programming, variable names must be one word. It's a rule. Okay, it's a rule. Okay. Very, very important. They must be one word. They cannot have a space in between them. Okay, so int my_num equal 5. It means put 5 inside my_num. And because I'm saying int, I cannot do 5.0. Okay, it's very important. Then float, my float num is now equal to what? 5.99. Okay, that one you can put a decimal number into it. Then double is also a decimal, so 9.98 is a decimal. Then character or char is a single character. So usually what we do is that we put single quotes around the character. So quote D quote. You see that? There are quotes around the char variable or the char variable. Then Boolean. Boolean, you just write true or false. Some programming languages, you have to do capital T or capital F. But most programming languages, you don't do any capital. It's just lowercase true or lowercase false. Okay. Now, when you have multiple variables you are creating, and they are all the same type, you don't have to create them one by one. Okay. You can just put them all together and create them once on one line. How do you do it? You write the data type, you write the variable name, and then you separate the next variable with a comma. Okay, so the example down here, you can see int num1, comma, num2. It means num1 and num2 are both integers. Okay, then we have another example, float first price equal 14.9, comma, exchange rate, comma, temperature equal 28.6. So it means all 3 variables, first price, exchange rate, temperature, are all floats. Now you can only do this if they are the same type. You can't pick maybe a num and pick a float and put them all on one line. No, it's not possible. Okay. There's a hand up, Mr. Kojo. Mr. Kojo.
Yes, sir.
Yes, sir.
Whilst you are presenting, you said that the double represents decimal, right?
Yes.
But in fact, this particular slide that we are seeing,
yes,
I'm seeing floating point number. So I'm wondering, because all the other ones you have represented them by especially the int is integer, right? And the float is floating.
Okay. If
you have made it floating point.
Oh, if you were following me, did you maybe you didn't look at this? I did explain over here that both float and double are decimals. Okay, we call decimals floating in programming. That's how we call them. It's not a matter of myself making that assumption, but that's how we call them. We call them floating point numbers. Okay, now the difference is in the size. Notice that the float is quite smaller than the double. In fact, double is double the size of the float. That's where it gets its name from, but it's actually a float. Okay. Are you seeing that, Mr. Kojo? Are you seeing that double is just double the size of 4?
Yes, sir.
Yes, that's where it gets its name. Okay. So if you have a very big decimal, we put it inside double. And if you have a small decimal, you put it inside float. That's the only difference.
Right.
Okay.
Okay.
Another key difference is the accuracy. Okay. So if the decimal is, when we say the decimal is big, what we mean is that maybe after the decimal point, there are so many numbers, and we want to keep all those numbers correct. Okay. So if you want to do that, you use double. But if after the decimal point, the numbers are not much, they may be less than 7. Okay, you keep them inside float. Okay, so have I answered your question?
Yes, please.
Okay, so both float and double are floating points. Okay, but float is a smaller floating point, while double is double the size of float. Okay, Mr. Owusu, yes.
Hello, sir.
Yes, sir.
Please, I've seen you making use of semicolon. What role is it playing there?
Oh, okay. Because initially this course we used to teach it with C++. So that's why the slide has it in there. Okay. Hello.
Okay.
Yes.
Okay,
so in C++, we end every line. That's how we indicate the end of the line. Okay. That's why it's showing that over there. Okay.
So, sir, please, currently, which language are we using? These examples that
currently the module you are using the same module they use in block 1. So it's we're supposed to do just a pseudocode. So it's no language. We'll just move the language from it and then just build your competence one small till you understand the actual program. I think there's a course you do later on in program. I don't know, but maybe something like that exists. But I'll ask the course coordinator first. Okay, I need to ask him first. Okay, Mr. Purity, make it short. Okay.
Yeah, I'm here. Sir, please, can you go over just take a minute or two to re-explain the basic data type? That is we can declare variables using statements like the following. If you can just use a minute to just touch on that, I'll be grateful. Thank you.
I don't understand you. What do you mean? I don't understand.
The basic
you mean
data
I should do what do you call it? I'm not even finding the words. You mean I should go over what I just explained?
Yes, sir. Yes, sir.
Oh,
yes.
But where were you?
So my network. Very sorry, sir.
Oh, but you can watch the video. Oh, come on, gentlemen. We cannot be doing that. You can watch the video, okay? If you have a genuine question, I will answer it for you. Or you don't have, but oh, come on, please. Okay. There are so many people on the call. Okay.
Why are you laughing?
Okay. Let's go on. Okay. Then we have string data. So string data is any data which consists of a sequence of characters. Okay, so one sequence means just one or more characters. Okay, and then usually we enclose the sequence of characters in double quotes. Okay, so it depends on the programming languages though, but most times in most programming languages, strings are enclosed in double characters. Okay, so an example is the variable called val. Okay, VAL. So it's been assigned a value, enter the first number. Okay, then a variable called name has not been assigned any value. Okay, then later on in our program, we assign the variable name. My name is Peter. Notice that it has double quotes around my name is Peter. Are you with me? Okay, so let's proceed. So what can we do with strings? We can do several operations with strings. Okay, we can do an operation called concatenation. Concatenation means that you take two strings or more, two or more strings, and then you join them together to produce a single string. Okay, so for example, I create a string called string 1, and I put the word part, and I create another string called string 2, and I put the word time. Now, when I do string 1 plus string 2, I should get part-time as one word. Okay, because the computer knows that there's no way you can say you add P to T, you add A to I. You know when you do string 1 plus string 2, ordinarily our mind tends onto addition, but you cannot add letters. You can't do A plus B and get C. No. So what happens that when you have two strings and you do the first string plus the second string, the computer will take the first string, take the second string, and put it at the back of the first string. Okay? So that's what it will do. Okay? We call that type of operation concatenation or string concatenation. Okay. Any questions about data types? So these are the basic, these are the types you need to know for now. For now, these are the types. In fact, these types, if you understand them, you will survive most programming languages. Okay. Integer, decimals or floats, Boolean, characters, string. Those are the basic or some of the types you need to understand for understanding programming proper. Okay. My line is breaking. Okay.
Hello, sir.
Yes, sir. Yes, sir. Go on.
So with this, is it wrong? Is it wrong to put the part-time at once, or
is it wrong to what?
To put in the part-time, like if you want to put in part-time with the string part-time as just one.
Oh, why is it wrong? I'm just demonstrating a concept to you. I'm just demonstrating that if you have string 1 plus string 2, you will see part-time together. That's it. So you can create part-time anywhere else. Right? If you have string 2 plus string 1, you get time part. You understand the idea? The idea is just to show you that how you arrange it will be how you see it.
Okay. And that's known as the concatenation.
Yes. Attaching two strings together is called string concatenation. You do that with a plus sign. Okay. Yeah. So let's proceed to session 3, type conversion and casting. Okay. So when we're talking about type conversion and casting, we are talking about changing, like the word says, conversion. So sometimes you create data in one form. You don't need it in that form. You need want to change it into another form and use it. Okay. So type conversion simply means changing the value of the variable from one form or from one data type to another data type. Okay. Now, how do you do this? There are two main ways of changing. We have one called implicit type conversion. Okay, and we have another called explicit type conversion. Okay, now type conversion can also be called typecasting. Okay, so please take note of that. When you see typecasting and type conversion, they are the same thing. Okay, now with the implicit type conversion, it happens during runtime, right? What we mean is that, for example, you are a programmer and you wanted to add a decimal to an integer. Okay, maybe you do 2.0, then you do plus 1. Now, you will not get the answer as 3. Instead, you get the answer as 3.0. Why? Because the computer itself will do something, or the programming language itself will do something called implicit type conversion. It will take the data types and change the integer to a float. Because you see, float is a decimal. Decimal is bigger than an integer. Whenever you have a small type and a big type, the answer will always be a big type, because we need a place to put the extra information. Okay, so take note of that. Okay, or sometimes maybe you want to do maybe division, or you want to do or you have a number. For example, you have a string and a number. So I have a string, maybe my age is, okay, that's a string. Then I have a number 16. When I do my age is plus 16, what will happen is that the computer, because it sees that my age is a string and 16, but 16 is a number, it will automatically convert 16 into a string and now attach it, because you can't add 16, the number, to a set of characters. It's not possible. I hope you understand what I'm saying. You cannot take M and add it to 1 and get maybe a number or something out of it. Okay, you cannot take the Y and add to the 6 and get something out of it. Okay, but instead you can type, you can write my age is and put 16 at the back. So in order to put 16 at the back, it will now convert 16 into a string. Okay, so that type of conversion is called implicit type conversion or automatic type conversion. Okay, and then explicit is when you, the programmer yourself, when you convert the number yourself. Okay, sometimes you notice that, oh, if I convert this number from integer to string, or from integer to maybe double, or from double to maybe float, or from something to something, it will help you with your mathematics or help you make your programming easier. So you can do that in the programming. Are we okay? Okay, I think you're all here following. Okay, so let's see examples, or let's see practical demonstrations. Okay, so the first demonstration or the first example is what you're seeing over here, the implicit type conversion or automatic type conversion. So this occurs when the data type of one variable is assigned to another variable. So for example, I have a variable called AMT, or that's a short for amount. Okay, then that variable is a floating point. It's supposed to be decimal. Okay, but instead I put in a whole number. I put in the number 3. Now what will happen is that the computer or the programming language will automatically convert the 3 to 3.0. Are you with me? 3.0. So what it has done is that in order to fit the type of data into the variable, we have automatically converted the variable to suit the type of data. Okay. Then another example, which is similar to what you saw earlier, is double D equal to what? 5. So double D equal to 5. We are expecting 5 to be maybe 5.0. Okay. but instead we get the whole number 5. Now the computer will automatically convert the whole number 5 to 5.0. Then another example is that we have an integer called BAL, balance. Okay, now instead of putting in the number 100, you see 100.57, but we have created an integer variable, so the computer will throw away the 0.57. Okay, when the computer does that, we will lose the information, and that is how the computer will work at this thing. Sometimes some of you try to do something like that. You try to create one variable and then put in another different kind of value. The computer will most times try and throw away those type of values and put in its own value. Okay, so the one with the balance, int balance, instead of getting 100.57, we will get 100, because balance is supposed to be a whole number, not an integer. Okay, then with explicit type conversion is when you, the programmer, you manually convert data from one type to another. How do you do it? In most programming languages, you put a bracket, okay, we call this parenthesis, around the data type, and then you put it in front of the value. So what this one will do is that it will convert the number 5 to 5.0, which is a double, a floating point, or a decimal number. Then this one, 14.3, when you put int in front of it, we will throw away the 3.3, and you get only 14 when you try to work with it. Okay, we will get only 14 because we want integer. The decimal part will be truncated or be thrown away. Okay, then you can even use it in calculations. So for example, we want this 9 to be 9.0. Okay, so how do we force the 9 to be 9.0? We put float in parentheses in front of the 9, and once we do that, 9 becomes 9.0. Okay, I think there's a hand up by Esther. Esther,
Sir,
let's hear you.
So with these examples, it looks like they are dealing with only numbers. So it's character and string.
We can do character, string, we can do we can do character, single characters as well. Okay, you can do complex types, but it will require me to teach you programming, which to teach you a particular language's way of doing it. Okay, so I don't want to do that now because the scope of this class doesn't go there. Okay,
thank you.
Okay, so you can do it with other types, okay, but you require much more complex ways of doing it. Okay, we call something type cohesion. Okay, so we can do that over there. Okay, but it's understandable now, right? Most of you understand what I am referring to. Okay, thank you. Okay, so let's go to the next segment. Okay, so now an important issue is that, you see, when you do type conversion, you might lose vital information, which will make the number precise or will make the number accurate. For example, if you forget and you create an integer variable, but instead you put in a decimal, the programming language will throw away the decimal and leave only the integer part. Okay, maybe the decimal part is also important for your calculations, but without it, your calculation will not be accurate. Okay, so sometimes there are issues. In fact, you have to take your time and assess the computer program and ensure that the program doesn't have any of these problems in it before you can give it to the customer or the client. Okay, so you need to, as a now, why is it important that we must ensure that the information or the kind of data we are using or we are manipulating within our program is accurate. Why is it important? Number one is that we need data integrity because we want our information to be precise. Okay, we want to prevent the loss of vital information like decimal numbers. Okay, remember, like I said earlier, if you do not enter the right, or if you don't enter the right data type, or the data type is maybe truncated, or the data is truncated, you might lose the decimal points or lose something important. So it's important that the data is precise. Then another key thing is that the operations, we want data integrity because the operations must also be what? Consistent. Okay, we want to ensure that when we are adding, we get maybe the equivalent, or we get the equal number. When we are multiplying, or when we are doing something, we get the same data type or something. You understand? You want the type to be the same. So, for example, you cannot add two numbers, maybe two integers, and then you'll be getting a decimal number, and you'll be just sitting there as a programmer and accepting that. No. Okay. What it means is that something is wrong somewhere. You need to take your time and correct the data types, or correct the type of operation happening, so that you can get the required type of data. Okay. Then it's also important when you are trying to validate your info. Data validation simply means ensuring that what you have is what you set out to get. Okay. Then error handling is when you have errors. How do you handle those errors? Okay. So it's important that all of those things are correct. And once you get these things correct, you get good data integrity. Okay. Okay. I think if there's any question about the session we just did, then if there's nothing, we proceed to the next session. Okay. Okay. Let's proceed to the next session. Okay. Okay. Now in session 4, we are going to talk about constants and literals. Okay. So constants and literals. Now, what's a constant? A constant is a value which will not change during execution. Okay. So an example is the number pi. I believe most of you remember the number pi, right? Most of you should remember pi. Pi is the value for the radius of the diameter of the Earth. Okay. Now, because pi is, I think it's around 3.1. I think it's around 3.1415 something. It's a long, very long number. Because it will never change, we put it inside a value or a variable. Now, when we put such a number inside a variable, we don't want people to be changing that number. Okay? So what we do mostly in programming is that we make constants capital. The name of the constant, we make it capital. In some programming languages, there are special words you can put in front of the name so that once you create them, nobody can change them. An example in C++ is the word called const, C-O-N-S-T, const. Okay, so you put that word in front of the name. Once you put that word in front of the name, when you create it, nobody can change what is inside. Okay. Another example in programming is in Java, we have a keyword called final. Okay. So you put the keyword final in front of the name, nobody can change what is inside. Okay. So I show you an example of how we use a constant. So over here, the constant is what? Pi, P-I. Okay. And it has a value 3.14159. Okay. Now, radius is just a normal variable. What it means that radius we can change, but constant, I don't want anyone to change pi. So because pi will not change, I made the name capital, but radius is lowercase. Then we know that the area of a circle is what? Pi r squared. R squared is just r times r. Okay. So when you do this, you get an answer, and the answer is put inside what? The variable called area. Is that understood about? Do you understand what I mean by the rationale behind constants? constants. Do we all understand the rationale behind constants? Okay, that's good. That's good. Okay. Okay. So let's talk about literals. So literals are simply value. When you have a value, every value automatically is a literal. Okay. So we can have numeric. Numeric means number variables. Okay. So that number can be a whole number with an integer, or that number can be a decimal number with a float. So an example over here, we have what? An integer literal is what? An example is what? Apples. Apples contain the number what? 5. 5 is the numeric literal. It's the value, the number value, which is inside the variable apples. Then 3 is the numeric literal. Okay, which is inside what? Oranges. Then we have another example here. We have total fruits is equal to what? Apples plus oranges. So we are not adding apples to oranges, but we are adding the numbers 5 plus 3. And that 5 plus 3 will be put inside the variable called total fruits. Okay, so you get 8 in total fruits. I hope you all understand that. Okay, so the number itself, when you put it inside, that is what we call the literal. And then a floating point or a decimal example is what you see over here. So we have circumference is equal to 2 pi r. So we need pi. So pi is the floating point literal. Okay, sorry, or 3.14159 is the floating point literal. Then radius 2.5 is the floating point literal. When we do 2 times pi times radius, the number we get, which is 15.70795, that is the floating point literal, or the value which will be stored inside circumference. So circumference will contain that number. Okay. Then sometimes we can store base 2. In programming, in mathematics, most of you did number bases. Okay, you remember number bases. Okay, so binary is when we are working in base 2. When you want to store a base 2 number, you just put the number 0 and b and the letter b in front of the number. Okay, so an example over here, I have 1010. I just put 0b in front of 1010. What it means is that you can't have the number 2, you can't have the number 3. The only numbers in binary are 0 and 1. Okay, so please take note of that. So 1010 is the equivalent of what? 10 in base 2. Then if you want to store base 16, we call it hexadecimal. We put 0x in front of the number. So if you want to store, for example, the number 10, 10 is what? A in base 16. Most of you will not have to worry about all of these things, but we just have to state them on the record so that you know that this one, all of these things can be done in the program. Okay. Then another way too is that sometimes if the number is large, you can use scientific notation. Those of you who did science, you remember you can write 1.0 times 10 raised to the power maybe 5, or maybe 9 times 10 raised to the power minus 20. That type of notation, you can also write it in programming. How do you do it? You write the variable, and then the literal is the 4.37e plus 13. What it means is that we have 4.37 times 10 raised to the power 13. Okay. Most of you are familiar with the E on your keyboard. Okay, sorry, on your 991ES calculator. It's on the 991ES calculator or SE calculator. You will see that E, the small e, it represents times 10 raised to the power. Then you put there whether you want to do negative or positive beside it. So whenever you see E in the number, it means you are doing times 10 raised to the power the next number. Okay. So in this example, gravitational graph underscore constant, you have 6.67430 E minus 11. What it means is that you have 6.7430 630 times 10 raised to the power minus 11. I hope it's clear. Hopefully, most of you might never have to use any of this, but if you need to use them, then in most programming languages, this is there and it's possible. Madam Esther, you can go on.
Sir, please. Looks like after the explanation, like the first one, the OB101, and the semicolon that ends it, the forward slash, the 2 forward slashes that bring the explanation. If we are doing it, would we have to put it there, or you only brought it to explain to us?
Oh, just to explain. In programming, we call them comments. Okay, comments.
Okay.
Yes. So I brought them there just to explain to you. Okay. I'll come and explain comments too, but comments are notes we write for ourselves. Okay. So in programming, if you want to write something but don't want the program, you don't want the compiler or the interpreter to run it, you put it in a comment. So it's like an explanation. And I want you to understand what is there. That's why I'm trying to explain what's there. Okay. I hope we are all clear. Okay, I take it that we are all clear. Okay, next one. Then not only numeric or integer literals, we can also have what? String literals. String literals means that we have strings by a sequence of what? Letters. Okay. Oh, sorry, characters. Yeah. So, for example, hello world. Okay, that like most of you, if you're writing the first program in any programming language, you encounter this hello world program. Okay, so hello world, and because it's a string of characters, we put hello world in quotes. Okay, so you have to write the quotes and then you write the hello world and then exclamation, and you put the quotes after it. Okay, then I think I've already explained the concatenation. So this is another example to explain the concatenation. So you see name equal Alice. So Alice is a string literal. What it means is that Alice is the value inside name. Wherever you see name, which is a variable, it contains the word Alice. So here, if you see hello, comma, plus name plus exclamation, how are you? When we are running the program and we want to print the message, we will instead see hello, Alice, exclamation, how are you? Please be very circumspect over here, or pay particular attention. For variables, where we see the variable, we will normally see the value of the variable. Okay, we normally see the value of the variable. So you see hello Alice, because where you see name, whenever you see name, you replace it with what? The word Alice. So hello Alice, exclamation, how are you? Okay, then sometimes to you, we want to put special formatting. So sometimes you see these \n, we call them escape sequences. Okay, so what they do is that \n will force the next thing that appears to appear on a new line. So you see this is a multi-line text full stop on one line. Then because of the \n, you will see it spans across multiple lines, full stop, on a different or on another line. Then because of the next \n, you see, isn't it magical? So \n forces the computer to print each sentence that appears immediately after it on a new line. Okay? Then we have something called interpolation. Interpolation means just put the value where. So I did an example over here where you saw, I said that wherever you see the variable name, replace it with what? Alice. The same thing that applies over here. So here we have a string called message, and this string contains a sentence. Congratulations, your score is, then you see the variable score again. Now, variable score contains what? 95. So instead of printing congratulations exclamation, your score is score, the computer will instead print congratulations exclamation, your score is 95. Interpolation simply means that the computer will, wherever it sees a variable name, it will replace it with the value of the variable. Okay, so you can do concatenation, or you see concatenation is done when you want to do the plus thing, or you can do interpolation when inside the sentence you want to replace the variable value with the value of the variable. Okay, then sometimes you want to get special characters like CD sign, $sign, and the rest. Most programming languages have a way of generating special characters. Okay, so this example is that of the $sign, the small $sign for cent. Okay, cent is the $sign for I think coins, right? In the US. Okay, so this \U0082, right? So that one will generate that particular symbol, but there are different symbols for different code for different symbols. Okay. The last but not the least is Boolean literals. Okay, so Boolean represents any value which will generate true or false. Okay, so true is the literal. There are only two literals in Boolean. Okay, true or false. Okay, if you also write, for example, 5 less than or equal to 8, when you run that program, you will not see 5 less than or equal to 8. No, instead you will see true. Okay, the reason why you are going to see true is because when the computer evaluates that expression, it will return the value that expression generates. Okay, then here when you do 60 is not equal to 90, you will see true, because 60 is not equal to 90. I believe everybody knows that 60 is not equal to 90, right? Then here, when you do 20 is greater than or equal to 100, you will see false, because 20 is not greater than or equal to 100. Then here, you also see false, because 19 is not less than 6. Okay, so these are the true or false are the literals, the actual values we get from this. Okay, any questions about this so far? Any questions? I believe we are all paying attention. Any questions? Okay, Mr. Usu. Mr. Usu, please.
Sir.
Yes.
Please, I was struggling a bit to find the differences between literals and the constants. Please, can you show a bit?
Okay, so
hello, sir.
Yes, I'm here. Yeah. Who is that? Okay, so I was saying earlier that constant is a value that will not change. Okay, a variable whose value will not change. So if you want to create a variable that you don't want people to change, or you yourself to change the value, you create it as a constant. Like the name says, the English word constant means it's constant. It does not change. Okay. Whilst a literal is the value itself. Okay, the value that you put inside a variable, or the value which will appear raw in the program, is what we call a literal. So it can be a string, it can be a number, it can be a decimal, right? That's what a literal is. Okay, Mr. David. Mr. David, unmute yourself.
Hello, sir. Hello, sir.
Yes.
Thank you very much for the opportunity. Please, so whilst you were discussing on the strings and then the literals, you made mention of the backslash, that
yes,
it prints.
Yeah.
When you bring it before a code, it prints. It means the code or the whatever you have typed should be print out. Please, can you elaborate on it again?
Okay, you did not hear me well. I didn't say it should print out, but I said that when you they are called special. They are called escape sequence. In fact, there are a few of them. In fact, they are.
I don't know if you can bring that slide on. Hello, sir. I don't know if you can bring that slide on so that
Are you okay?
Yes, sir. Yes, sir. Please go back that area again.
But the same thing I would say, you don't worry. It's not necessarily like what you said. I don't know how you are hearing what I'm saying, but I'm saying that it's called, there are a set of special characters we use to do different things. So for example, if you want to force the computer to print a sentence, a new sentence on a new line, okay, you do \n. What it tells the computer to do is new line. \n forces the thing that appears after it to appear on a separate line or a new line. You know that if you have written in a notebook before, right? You know there are lines in the notebook, okay? So you're writing on one line, and then there's another line under it, there's another line under that, another line under that, right? So that's what basically does. It lets you, wherever you put it, it will break the sentence and let the next sentence appear on another line. That's what it does. I don't know what you heard, okay? But there are others. In fact, there are so many of them. When you start to learn the actual programming, like C++ or C or Java or any of those actual programming, you see /C, /S, /T, /. There are so many of them, okay? They are called escape sequences. They are used to force the computer to do certain formatting. Calm yourself.
All right.
Okay. Let me finish answering this one, okay? So they are used to force the computer to do formatting, special kind of formatting, okay? So come again with your.
So what I was trying to say is that does it apply to all programming languages, or is specific to a certain programming language?
Okay, so the ones I have used so far, it works. I think it works in C, it works in C++, it works in Python, it works in Java. I think it works in C#. Yeah. So those are the ones. It works in Kotlin. Right. There's a language called Kotlin. It also works in Kotlin. So I think I work in most of the programming languages. Yeah.
All right. Thank you very much, sir.
You're welcome, sir. Okay. Yeah. So yeah. Okay. Now we've reached the part I like the most. Okay. Okay. There's a question on the chat. It says what? Oh, thank you very much. It's a clarification. So those of you who may, I don't want to show programming right now in the class, okay? But those of you who may not really understand it, when you look at the chat, the gentleman has shown you what you will see when you try to do the \n. Okay, so you see my name is Yao on one line, then under it, you see another sentence, I am 45 years old. Then under it, you see another sentence, I'm from Kumasi. What it means is that in between the full stop from the Yao and the I, the computer saw \n and it moved the I am 45 years to another line. Do you understand that? Okay. So that is what's forcing, that is what will force the computer to move each sentence to a different line. Okay. Okay. And then another person also gave an example with HTML. Okay, I think there are some programmers already here. So in HTML2, we can force a new line by using the less than BR or greater than, right? It's called the brick. Okay. So where you put it inside the sentence, it will break the sentence into two and put the next sentence on a separate line when you format or when you render the HTML page. Okay. Yeah, thank you very much for that insightful addition, my dear friends. Okay. So here, or in this section, we will look at operators. Okay, you are very familiar with these ones, so we should not struggle too much with it. So we'll look at several operators in programming. We'll look at arithmetic operators in programming. We'll look at relational operators and operations that we can do with them. We'll look at logical operators, and then finally, we'll look at how we can write mathematical expressions in programming. Okay. So first and foremost, when we say arithmetic operation, in fact, when we say programming is just a very big calculator. Okay. Programming is just referring to a very big calculator. And what it means is that you can do lots of incredible mathematical operations in programming. Okay. Now, in order to do mathematical operations in programming, you need to know a few of the operators. So we have what we call arithmetic operators. So the arithmetic operators are operators which allow, oh, someone cannot hear me. Have I ceased to be heard? Can you hear me? Please, can you confirm whether you can hear me? Okay, you can. Esther can hear me. Okay, a few of you can hear me. Okay, so gentlemen, kindly check your audio. Maybe check your audio. Mr. Kojo Anderson, kindly check your audio, okay? Thank you very much for confirming, okay? So arithmetic operators are the basic operators we use in programming, okay? And even not just in programming, in mathematics, okay? So we have addition, we have subtraction, we have multiplication, we have division. Then, because we are doing programming, we have exponentiation, okay? Raise the power, okay? Most of you call it raise the power or power of, okay? Then we have modulo, okay? So I will explain what each one does, since I don't know whether most of you understand everything or not, okay? So when you want to do addition of two numbers, you use the addition, okay? So an example is what I've given on the side, on the file right hand side. You see example, and then I've explained what it does. So addition, this is the sign you use in programming, okay? You use the plus sign, okay? And what it does is that it takes the first one, second one, adds them together. Okay, so here we'll get 11. So results will contain the number 11. Then subtraction, what it does is that it subtracts the right one from the left one. So over here, what it will do is that it will take 12 and subtract 18 from 12. Okay? Then the answer or the result is what it will put inside the results. Okay? So here you get what? -6. Okay? Then multiplication is not X, okay? But in programming, multiplication, we represent it with what? With star. Okay, I don't know if you can see it, but on your keyboard, there is, if you press the shift, and you press 8, you will see a character. It's a special character like a star. Okay, so what it does is to multiply the two numbers. So 3 star 4, the result will be what? 12. And 12 will be put inside the variable called results. Okay, then division, there is no division sign with the bar and the 2 dots. Okay, so on your keyboard, there's nothing like that. But if you want to do division in programming, you use the the backslash. Okay, so the backslash. So we will divide the numerator with by the denominator. Okay, so 50 divided by 2. Okay, so you get 25. Okay, then if you want to do exponentiation, okay, you want to find the exponent, the power of, or raise something to the power of something, you use the caret. Caret is the special character on the 6. Okay, so you press shift 6, you should get caret on your keyboard, and then so here you have 4 raised to the power 3. And how do we write it? We write it as what? 4 caret 3. In some programming languages like Python, it has its own special symbol for exponents. Java also uses functions for exponentiation. So please take note of that. Okay.
Then modulo arithmetic, we use the percentage sign. So modulo is used when you want to find the remainder. Okay, so for example, we want to find the remainder of dividing 91 by 2. When you divide 91 by 2, what's the remainder? So you get modulo will return the remainder. Okay, so when you divide 91 by 2, I think you get 45, remainder 1. Okay, so the remainder is 1, and 1 is the answer we put inside results. Okay, so I put a slide here to explain each one by one. We have addition. So these are some examples. You can add 2 numbers at a time. You can add 3 at a time. You can add 4. You can add as many you want, because programming languages are usually very big calculators. You can do addition like that. Then subtraction too, you can do same. You can add 2 at a time, or you can add variables with the values inside, or you can add more than 1. You can subtract more than 1 thing at a time. Okay. Then multiplication too, you can multiply 2 variables with values inside, or multiply literals themselves. Okay, the numeric literals themselves. Then division too, you can put the literals inside variables and divide them, or you can divide the literals raw like that. Okay. Then, like I was explaining, modulos simply refers to remainder. Okay. So if you do 15 modulo 2, what it means is that divide 15 by 2, the remainder is the answer. When you divide 15 by 2, you get 7, but the remainder is what? 1. Okay, so 1 is the answer of 15 divided by 2. Okay, so 15 modulos 2. Then 120 modulos 2 is 0. Why? Because 120 divided by 2 is what? 60. There's no remainder. Okay, 60 by 2 is 120. There's no remainder. So 0 remainder. Okay. Then 203 modulo 5 is 3. Why? Because 203 divided by 5 is what? 40. 40 times 5. Okay, is 200. So remainder is what? 3. Then 139 modulo 16, the answer is 11. Why? Because 139 divided by 16 is what? 8. But the remainder is what? 11. So the remainder is what you return for modulo arithmetic. Is it clear? I hope it's clear. Okay. This one, we've done some in primary school and the JSS and those secondary school, those places, but we still have to stress on them because we are now doing programming. Okay. And then I put some examples here for all of us to visualize and try and see what the answers are. So let me change this one. Let me change this one. So let me change this one to maybe 4, and then let's change this one to maybe 2. Okay. So 4 plus 2, that will be 6, and then 4 minus 2, that will be 2. Then 4 modulo 2, that will be 0. Then 4 times 2, that will be 8. And then 4 divided by 2, that's I think 2. Yeah, so that's 2. So please take note of that. Very simple. Everybody can understand what's going on. When you see the variable, you just replace it with the value or the literal. Okay, we have talked about this just now. Okay. Then sometimes you want to do something like add or indicate whether a number is positive or negative. In programming, you can indicate whether a number is positive or negative by putting either the plus or the minus in front of it. Okay, so you can see that if I want to write positive 5, I can write plus 5, or you can write 5. Okay, if you write 5, it's still positive, but you can also write plus 5 to indicate that the number is positive. Okay. Then if you want to write negative 5, you can write minus or hyphen 5. Tell the computer that, oh, the number is what? Negative 5. Okay. So negative, you have to put the minus in front of it. Okay. Then sometimes you want to do addition, plus 1. Okay. So in programming, we have a shorthand. We call it the unary, the increment operator. When you do plus, what it tells the computer is that add 1
to the value I'm holding. Okay, so plus plus 5 means that add 1 to 5, so you get the answer what? 6. 5 plus plus, that's the same thing, you get 6. Then minus minus is the decrement operator, decrease by 1. Okay, so minus minus 5 means subtract 1 from 5. The answer will be what? 4. So you get 4, or 5 minus minus will do the same thing, you get 4. Are we okay? So that's what that means. So plus 10 is equal to 10, minus 10 is equal to minus 10, plus plus 10 is equal to what? 11, because add 1 to 10, you get what? 11. Minus minus 10 is equal to 9, because subtract 1 from 10, you get what? 9. Okay? Then when you do 10 plus plus, you get 10 for the first time. Then after you run it again, you get 11. Okay? So please take note of that. Then when you do 10 minus minus, you get 9 after you run it for the first time. So the first time you run it, you get 10. Then the second time you get what? 9. Okay, so please take note of that. Then in most programming languages, we can do shorthand. Okay, so we call this the combined operator. Okay, so the combined arithmetic operator. So for example, if you want to do, so I wrote the actual thing over here on the left hand, on the right hand side, and then I wrote what it means or how you can write it shorthand on the right hand side, and then the operator alone on the left hand side. Okay, so let's look at the first operator. If you see plus equal to, what does it mean? How you can write it is that you can write x plus equal y. What it means is that you have x equal x plus y. Okay, so it means you have x on both sides of the equal to, and then you only write the x once, and then you write the plus equal y. It means add x to y and put the answer inside x again. Okay, the next one, if you want to do shorthand for minus, okay, you write it as what? For example, if you want to write x equal x minus y, because there's x on the left hand side and there's x on the right hand side, you can write x minus equal y. It's a shorthand for writing x equal x minus y. Remember, the x has to be on both sides in both cases. Okay, then if you want to write x equal x star y, or multiplication, right? X multiplied by y. Because x is on both sides, you can shorthand it and write x star equal y, the same as having x equal x star y. Are we okay? Then if you want to write x equal x divided by y, because x is on both sides, you can write x backslash equal y. It will stand for the same thing in program. Okay, then if you also want to write x equal x modulus y, you can also write it shorthand as what? X modulo equal y. Okay, then also if you want to write x equal x caret y, which is x raised to power y, you can write that x raised to power equal y, because there's x on both sides. So this is a shorthand. Programmers like to write in shorthand, and so you must also learn so that you understand it when you see it. When you see anything like this, this is what it means. Remember, x and y can be replaced with different names, okay? But basically what I want to explain is the plus equal, the minus equal, the times equal, the divided by equal, the modulus equal, and then the raised power equal. Okay, I hope most of you understand it. I hope most of you are understanding and picking it small. Okay, that's good. That's good. Okay, then it is also important to note that, yes sir, you have a question?
Yeah, please. So I would like to know, if you want to use the percentage itself, what do you use?
There's nothing.
Maybe you want
like
to find a percentage of.
So you do the calculation, all right? Hello?
Yes,
Is
sir.
it gone? So you do the
No.
calculation. So you want to find 15%, right? 15%
Yes.
is what? 15% is what? It's 15 over 100, right? Right?
Oh, okay. So in this case, you can't use the sign.
No. The sign there, no. No. In programming, the sign is an operator. You cannot use the sign. Okay?
All right, sir.
Are you there? Yeah.
Yes, sir.
So you understand me, right? The sign cannot
Yes,
be
sir.
used.
Yes, sir. Yes,
Yeah.
sir.
Okay. Yes, Mr. David.
Sir, please, I want to clarify something here.
Okay.
The slash we are using here is which one?
Which of this? Which one are you referring to as slash?
Yeah, you see, you made mention of the backslash, and I want to know
Yes,
whether
yes.
is it the backslash or the forward slash, please?
Oh, but I just said backslash. Oh, it's not called backslash.
I think this one is rather forward slash. That's why I was a little bit confused. So that's why I wanted to clarify.
Okay. So it's the forward slash. A gentleman has also said forward slash. Okay.
Thank you very much. Thank you very
No
much.
problem.
Thank
No
you.
problem.
Right.
Okay. But you understand the general concept, right?
Yes, sir. Yes, sir.
Okay, that's good. Okay. Then when you have sometimes you can have what we call a mixed expression. Mixed expression is when you have two or more of the logical operators. Okay. You have two or more of the, you have maybe addition, subtraction, multiplication, division, mix them in an expression. How do you determine which one is the first to be done? Okay. In primary school, we learned about board mass, if you remember board mass, right? So, but in programming, because board mass doesn't take care of modulus and does not take care of exponentiation, because at that level you are kids, we don't add that one. So now that you are adults and we want to do programming, we must add that one. So in most programming languages, or in fact in all programming languages, we need to specify the order of operation or the order of precedence. Which one should be done first? So when you see a mixed expression, it follows this rule. The acronym is PEMDAS, okay? With P standing for what? Parenthesis, okay? Please give me a minute. Okay, thank you very much. Okay. Okay, so you first have to run all the brackets. Okay, in programming, like I said, we call the brackets parentheses. Okay, so it's the same thing, brackets. If there are more than one bracket, which one should you do? So that is where the left to right rule we the left one. When you are children, we just put 1 or 2 brackets, but because you guys are adults, you can have several brackets. Okay, so the rule says that do the brackets first. But if you see more than one bracket, which one should you do first? You should always do the one that starts first from the left, and then do the next one, and the next one, and the next one, all the way to the right. Okay. The next one says that do the exponents. Okay, so the exponents too, if there are more than one, which one should you do first? Here, you should also do the left one first. So you start from the left and work your way to the right. Okay. The next one says that multiplication, do the multiplication or do the modulus or do the division, depending on which one appears first from left to right. Okay, because multiplication, modulus, and division, they all have equal rank. Okay, what it means is that if we see multiplication, division, and modulus in an equation or in an expression, the first one that we see on the left should be done first, then the next one on the left, then the next one on the left, all the way to the right. Okay, so it means sometimes we can see the modulus first, sometimes we can see the division first, sometimes we can see the multiplication first, but they have equal rank, so you have to do the left one first. Then addition and subtraction too, they have equal rank. So here too, you do the left one first. Okay, so when you follow this one, you will get the same answer that the computer or your computer program will give you. Okay, so this is how programming languages, this is how your computer is generating an answer for everything, for every mathematical expression you give it. Okay, I hope we understand it. So I have some examples. I'll show you. So number one, so we have 2 plus 3 times 4 minus 15 modulus 2. So amongst this mixed expression, which one should we do first? So based on PEMDAS, we should ask ourselves, is there any brackets? Oh no, there's no brackets. Okay. Is there any exponentiation? Oh, there's no exponentiation. Then we ask ourselves, okay, between multiplication, modulus, and division, which one appears first from left to right? So based on our observation, we can see that 3 times 4, the times or the multiplication appears first from left. Okay, so it means we will do the left one, we'll do the multiplication first. Okay, so we do the multiplication, we do 3 times 4, we get 12. So we have 2 plus 12 minus 15 modulus 2. Then we apply the rule again. We see that modulus has higher power or higher order than addition and subtraction. So we do 15 modulus and 2. We get 1. So we have 2 plus 12 minus 1. Then between addition and subtraction, because they have equal powers, but addition appears first from left, we do 2 plus 12, we get 14. Then we do 14 minus 1, we get 13. So the final answer will be 13. If you use your 991 Casio calculator, you get the same answer, 13. Okay? Or if you use a computer program, those of you who know some programming, if you use a computer program, you should get the same 13 as an answer. Second example, in this example, we have 3 times 7 minus 6 plus 2 times 6 divided by 4 plus 6. Now we have multiplication, we have subtraction, we have addition, we have multiplication again, we have division, we have addition. Which one should we do first? We should always do the left one first. So we should look at PEMDAS, okay, parentheses, exponentiation,
multiplication, modulus, division. So based on this one, we have 2 multiplications, but the one that is first should be the one on the left, because we work from left to right. So 3 times 7, we get what? 21. Then the next one is what? 2 times 6. So 2 times 6, we get what? 12. So we have 21 minus 6 plus 12 divided by what? 4 plus 6. So the next is the division. So 12 divided by 4, we get 3. We have 21 minus 6 plus 3 plus 6. So we have more subtraction, we have addition and addition. So the next one to be done next is subtraction, because it is first from left. So we do 21 minus 6, we get 15. Okay, so 15 plus 3 plus 6. We add the left one first. So 15 plus 3, we get 18. Then plus 6, we get what? 24. So the final answer is what? 24. So the PEM, what it does is to help us understand how our computers are generating the answers they are generating for us. Okay, I hope we all understand it. Okay, I hope we understand it. Okay, that's good. That's lovely. Okay.
So I think the addition is supposed to be the subtraction is supposed to be done last too.
Why? I just explained.
According to the per mass, is it not addition then subtraction last? The addition comes before the subtraction, say.
No, you did not listen to the part I said, the left one first. It's called left associativity, left to right associativity. So we work from the left to the right.
Oh, okay.
Yes. So the one that appears first on the left will be done first. If addition appears first on the left, it will be done first. But if subtraction also appears first on the left, it will be done first. When you were in primary school, they were supposed to have told you all of those things, but they didn't tell you because we were all so stubborn and we didn't listen to anything.
So they didn't.
Yes, but if you go online and go and search operator precedence, it will list it for you. You will see that in the books or in the books that they used to teach the kids, it's there that they should start from the left to the right, but they don't mention that one in school. Okay, so that is how your computers are evaluating expressions. Okay, left to right, because we read, because you are English readers, we read from left to right. Okay, so you should, we always do the mathematical expressions from left to right. Then those are not the only ones. Arithmetic is just a fraction of the whole thing. We have what we call relational operators. These are the operators which are used for Boolean operation. Okay, so when we say Boolean, have it in mind that we are doing true or false. Okay, so these operators in programming, they only result in true or false. Okay, so we have the equal to operator. Okay, this is the one we use to compare whether two things are the same or not. Okay, I told you in programming, single equal to is not, it is for assignment. Okay, so when we put two equals to together, it tells the computer to compare two things. Okay, then greater than, most of you already know what greater than represents. Okay, greater than checks whether the first one is bigger than the second one. The answer also here is what? True or false. So an example is 12 greater than 7. The answer is what? True, because 12 is greater than 7. Okay, then less than here checks whether the first thing is smaller than the second thing. So an example here is 10 less than 13. It is true because 10 is less than 13. Okay, then in programming, when you put exclamation and equal to together, we call it not equal to. So it checks whether the first thing is not the same as the second thing. Okay, so we have 19 not equal to 19 is what? False. Why? Because 19 is equal to 19. But if we had maybe 19 not equal to 12, it will be true because 19 is not equal to 12. Okay, then we have greater than or equal to. Okay, so to check whether the first thing is bigger or the same as the second thing.
Okay, so here 180 greater than or equal to 170 is true because 190 is bigger than the second thing. Then less than or equal to, here it will check whether the first thing is smaller than the or the same as the second thing. Okay, so here 21 is less than or equal to 16 is false because 21 is smaller than 16. Are we okay? Then logical operators are used to combine the relational. Sometimes you want to do complex operations. So how do we combine relational operators? We use the logical operators. Okay, so in programming there are 3 of them. We have the AND. Most programming languages use the ampersand. Most of you are aware of this sign, right? The name is called ampersand. Okay, then if you want to do logical OR, we have the pipe. Okay, then if you want to convert a true to false or a false to true, you use the exclamation operator. Okay, the exclamation operator. So let's check it out. So for example, if you want to do 12 is greater than 9, and also want to check whether 10 is the same as 19, and then want to combine the answer of both, you can use the AND operator or the ampersand. Okay, so you see 12 greater than 9, the answer to that one is what? True. And then 10 is equal 19, the answer to that one is what? False. So true and false, the answer is what? False. I'll show you why or how I'm determining the true or false. Okay, then 30 not equal to 31, the answer is true. And then 17 greater than 23, the answer is what? False. But true or false, the answer is true. Okay, then the not only works on one. Okay, so on one operation. So what you have to do is to get the not, you have to finish the operation before you apply the not. Okay, what the not does is to convert the true to a false and the false to a true. Okay, so what will happen over here is that, is 45 less than 100? Yes. So the answer is what? True. The not of true is false. Okay, so that's what it does. Okay, so I'll show you. This is a table which you can use to determine the answer to true or false answer. For example, if you find if you are finding true and true, the answer is true. True and false, the answer is false. False and true, the answer is false. False and false, the answer is false. But if you're also finding true or true, the answer is true. True or false, the answer is true. False or true, the answer is true. And false or false, the answer is false. Okay, so you can see that the OR operation and the AND operation. But for the not, you can only pick one of them and convert it. So true become false, true become false, and then false will become true, and false will become true. Okay. Okay, so I put some example over here as well to help us all understand. Okay, so int A is equal to 9 and int B is equal to 12. So when we check if 9 is greater than B, we get false because 9 is not bigger than 12. Is 9 smaller than 12? Yes, so we get true. Is 9 bigger or equal to 12? False, because 9 is still not bigger than or equal to 12. But is 9 less than or equal to 12? Yes, 9 is less than 12, so we get true. Then is 9 not equal to 12? Yes, so it's true. Is 9 equal to 12? No, so it's false. And then you can do a combination of true or false. So over here, A is 50 and B is 18. So 50 is less than 10 is what? False, because 50 is not less than 10. Then 18 is greater than 5 is true. So if we have false and true, the answer will be what? False. So false will be put inside the result variable. Then 13 is not equal to 7. The answer is true because 13 is not the same as 7. Then 19 is equal to 10. The answer is what? False, because 19 is not equal to 10. Then if you have true or false, the answer is true because true or false, the result in the table was what? True. I hope we all understand how to generate that one. Okay? Yeah. Okay. I'll close right now. I think it's 7 o'clock.
Then finally, I want to also help you understand that when we are doing programming, we can't write the same way we write in, okay, there's a hand up. Okay, there's a hand up. Mr. Abdu.
Sir.
Yes, sir.
Sir.
Yes, I just responded.
In other languages, yeah, they also have question mark, or it's not part of this.
It's called a ternary operator. I was showing
okay.
in the book,
what does it mean?
in the material. I have to show you the logical, the comparison operators, and the arithmetic. So that it's not ternary operator is not part of those three. It's another operator altogether. Okay. Hello.
Okay, sir.
Yes. So ternary operator is when we get to conditional operators. That's when we will discuss ternary operator. Okay, it's not part of this one. Okay. Okay. So let's proceed. So how to write mathematical expressions? Now, you cannot write the way you write on paper, the same way in programming. Okay, programming will not work. For example, on paper, if you write 2x plus 3y, we cannot write the same thing in programming. In programming, we have to tell the computer that between 2 and x, they are multiplying. Because we all understand that 2 is multiplying x, right? And then 3 is multiplying y. So in programming, you have to write all the expressions explicitly. You have to write them out. Okay? If there's a 2x, you have to indicate that the 2 is multiplying the x. If there's 3y, you have to indicate that the 3 is multiplying the y like this. Also in programming, we write on one line. Okay, we write on line. You cannot do 2 over 3 and then you see the 2 on top of the over and then the 3 down. No, because it doesn't work like that in programming. So you have to learn how to use the forward slash to separate what is at the top from what's at the bottom. Okay. So for example, if you write something like this, the first one, you get an entirely different answer than when you write the second one. What the first one tells the computer is to finish all the thing in the bracket and then divide the answer by 3 and then add the answer to m. But what the second one tells the computer is to divide x by 3, then multiply whatever is here and add m finally. Okay, so they will give you two different answers. So you have to be very careful how you see the expression and how you represent the expression in programming. So I have some tips, but I have some examples for you later on. Okay. So for example, if you have 5 into bracket f minus 32 close bracket all over 9, this is on paper. Okay, on paper this one will work. In programming, it will not work. The programming language will not let you even write anything half close to this one. So you must write it in such a way that you get the same answer or result. So how do you write it? We know that 5 is multiplying whatever is inside the brackets, okay? But also, we have to finish the one on top before doing the one down here. So how do we force the computer to do the one on top first? By putting the one on top in a bracket. So 5 times into bracket f minus 32 close bracket, and then dividing it by what? By 9 and putting everything inside C. This is the same as what you see over here, okay? What you see up here is the same as what you see on this one line down here. Then, for another example, you have maybe the what do you call it? The sum of arithmetic progression, progression. So n over 2 into bracket 2 times 2n plus into bracket n minus 1 close bracket d close bracket. Okay, something like this. In programming, you cannot write this. So you have to find a way to write it so that you can get the same result. Now, notice over here that 2 is multiplying a. Notice also that n is being divided by 2, and then the answer of all of that is being multiplied by whatever is inside the bracket. Okay, and then n minus 1 is being multiplied by d. So you must write the expression the same way. How do you force it? You have to put this n divided by 2 into a bracket so that the computer will finish that one first before multiplying the answer with 2 times a. So 2 times a plus n minus 1 close bracket times d. So you have to write it so that it will generate the same answer. Are you with me? It's very important, okay, that you understand these things. Okay, then for another example, the quadratic equation. So another example, minus b square root of d raised power 2 minus 4ac. Remember, square root simply means everything inside here raised to power what? Half. Okay, square root means raised to power 1 over 2. Okay, then remember that we learned that exponentiation, you write what? B caret 2 or b raised to power 2. Okay, then here 4ac means 4 times a times c. Then also over here 2a means 2 times a. Then all over means that you have to finish the one on top before dividing by the one under. So how do you do it? You put everything on top in a bracket and then you write it minus b times, because b is multiplying whatever is in here, okay? Minus b times into bracket b raised power 2, right? Minus 4 times a times c, close bracket, raised power 1 over 2, because all of this is being raised power the square roots, okay? All divided by 2 times a. So this is what you get over here, okay? Then finally, I have a final example just to show you. So basically, you have to understand that when you start doing programming proper in the programming language, things will not appear the same way as they appear on paper. Paper is paper, okay? But programming language, they work with different rules, okay? Okay, any questions about that? Any questions about that? Then we go to the final session and then we will close it off for today. Any questions about that? Yes, sir.
Yes, sir. Good evening, sir.
Yes, good evening, sir.
On the on using the almighty formula.
Which one is using the almighty formula? Please be explicit so that I cannot understand you, okay?
I'm talking about the formula you're using is an almighty formula in relative math.
I do not understand what you are talking about. Which one is the almighty formula you're talking about?
He's referring to the quadratic formula.
Yeah.
Oh, but just say, okay, please go on. Sorry, go on.
Oh, it's okay. It's okay. Let's go on. Okay.
You are confusing all of us.
No. What I know and what I know that is what I know that's what they call it. So,
it's called the quadratic formula. It's called the quadratic formula. I just use it as an example to show you. Okay.
Okay.
Yes. That instead of writing it like this on paper, you see, on paper you can write it like this, but in programming, if you want to write a program to do the same thing, you have to write it like this. So it does the same thing you see over here. Okay. Okay. So now let's talk about input and output operations. Okay. Okay. So we want to learn how computers take program inputs or allow you to enter something into the computer, and then how to print out something onto the screen, and then how to do error handling. Then I'll give you a few things to do. So basically, because we are doing structured programming, you use a basic model. Okay. Our basic model for doing structured programming is called IPO. IPO stands for input, processing, output. What it means is that when you want to write a program, first ask yourself, what are the inputs? What inputs do I need for this program? Then when I collect the input, what do I do with it? We call it processing. What do I do? Then after doing what I need to do, what is the output I need to show? Okay, so it's a very simple process. Input, processing, output. You can't solve any structured programming without thinking of input, processing, output. I'll keep coming back to this because it's very important to understand programming in structured programming. Okay. Now, Okay, now let's look at inputs. So input is the part of your program which will allow you to collect some data from the user. Okay, so you can collect something like text, you can collect numbers, you can collect sound, you can collect light, you can collect a video, or you can collect any what sort of thing. Right? Inputs can be also typed from the keyboard. Now, before you collect input from the user, you must tell the user what you want. In programming, the statement that tells the user to give me something or to give the program something is called a prompt. P-R-O-M-P-T. The statement. It is used to tell the user what you want from the user. Okay? And usually in pseudocode, we write input something. Okay? But maybe if, because you guys are doing C++, okay, I'll teach you how to do cin. Okay, so cin, you write cin and then you write a statement after it. Okay, so let me show you how an example looks like. So in C++, you see a statement like this. The first statement, cout, is an example of a prompt. Okay, so that one is called the prompt. This one tells, or that statement tells the user what I am requesting for. So I'm requesting for an amount. Okay. Then the next statement is the input statement. Okay. Input statement. So that's the one that is collecting what you enter from the keyboard and putting the answer inside the variable called amount. Okay. Yeah. And then this one, the next one is a Python statement. Okay. This one is a Python input statement. Okay. Python is a programming language. This one is a Python input statement. So in Python, we write it all on one line. Okay, like that. So you see, maybe if I want to collect an integer, you see that I'll create a variable and then I'll assign the variable to int. And then inside there, I'll put the prompt. This part of the statement is called the prompt. Okay, so inside the prompt, I have a function called input, and then I have a small text telling us what I want from the user. Okay. Then in pseudocode, okay, in pseudocode, we have the statement written, a prompt written like write, and then you have the prompt, okay, maybe enter the radius of a circle. Then the next line, you take the radius of a circle. Okay. Then another example, maybe enter 3 numbers. So I'm expecting 3 numbers. So I have to do input for what? 3 numbers. Num1, num2, num3. All separated with what? Comma. Is that understood? Okay. Okay, that's good. Okay, that's good. Okay. Then once you do data input, you need to do processing. Now that you've collected something for the user, you need to use that thing you've collected to do some calculations. Okay. So in programming, we call that processing. That's the activity we call processing. So you can do, for example, you can do addition. So you can see sum is equal to var num1 plus var num2. So we are adding 2 variables and then we are putting the answer inside how do you call it? The variable called sum. Okay. Then you can see also that we have a profit is equal to a selling price minus cost price, and we are calculating the profits over there. So some statements like this are examples of processing. Okay, these ones are written in pseudocode. Okay, I'll come and explain what pseudocode basically is very soon. Okay, then once you have done the processing and you have the answer or you have the result, you want to show the user that you have the answer or the result. So how do you show the user? You do output. So you can do output by using what? Write, or using a word like output, or using a word like print, or using the word like see out, right? Any of those words will tell the computer or the program that you are doing output. So let me see out.
Okay. Okay, so answer is, then we can do concatenation of answer. Okay. So in C++, you see something like this, C out, then less than, right? Then you see the text, and then you see the concatenation, and then you see the variable which contains the answer. Okay. So these are all examples. Okay, these are all examples of several output statements you can have in your program, C++. Okay. 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 And then I mentioned earlier about comments. One of the ladies asked about the 2 backslashes. Okay, so in programming we have statements called comments. Comments are notes that you write for yourself, because you don't take one day to write the entire program if it's a very big program, and you want to always remember some of the things you wrote. You put in notes. Okay, those notes are what we call comments. Okay, so they are a form of internal documentation. Okay, when the notes or when the comment is on one line, we just do backslash. Okay, it's called single line comments. When the comment is on more than one line, you do backslash star, and then you write all the lines of comments. Then when you are done, you do star backslash. We call it multiple line comments. So this is a multiple line comment. That's a single line comment. Okay. They all do the same thing. Whatever appears inside is a comment. It's not meant for the compiler. It's meant for you, the programmer. Okay. So yeah. So I'll end the lecture over here. Any questions? Any questions? Any questions? I hope we all understood well, and then very few confusion here and there. I'll ask them to share the material with you, but I'll talk to the coordinator. Like I said, I'll keep talking to her to him to see if can make headway. All right. Please, can one of you send me the material you said you have? Can you throw it in the chat so that I can see it? I want to see it, please. Hello, can you hear me? Or you're all gone?
Is the course rep around? I think the
is there a
course
rep? Is there a course rep? Kindly, last week I asked you to get in touch. You didn't mind me. My number is on the course sheet. Okay, course rep. Please send a message to the course rep. He or she should get in touch with me. My number is on the course sheet. Okay.
Okay. Yeah, we don't have the course sheet. The course sheet. So how do the course rep get?
Oh, are you the course rep?
No.
I think they should have it. It's on the document they shared with all of us. So I think you should have the course sheet.
It's on the official page.
Okay.
Yes, it's on the official page. Okay, thank you. So please kindly ask the course rep.
Please, when you check on the timetable, the PDF, the one that was sent on the platform, the timetable with the times, the courses, and then the lectures and their names, their contacts are attached to it.
Yes, my number is there. It's on WhatsApp, so he or she can do WhatsApp or a call. Okay, I want to find out what you have, so I can prompt our people to send you a link to what we are also having. But it's the same programming, okay. But I want to know what you have. Last year I prepared some slides, so I don't know if it's the slides I prepared last year that you are having. Okay. So yeah, I just want to know that. That's all.
So the course rep is not around. So Clifford, I suggest please.
I'm around.
Okay, you're around.
I'm around.
Okay, thank you.
You heard my voice. Yes, I'm around.
Okay, sir.
Okay. So please get in touch. Okay. Okay. Thank you very much. Thank you. Is there any question? If there's no question, then we call it a day. Okay, then I take it that no question. So thank you very much. I'll see you, God willing, next week. Have a good week and Happy New Year in advance. Okay.
Same to you, sir.
Thank you.
Same to you. Same to you, sir.
So we are going to write this programming on paper or on our laptops.
On paper or what?
Hello.
Yeah, I say this thing. I will write on paper. Or we have to send laptops and be typing.
Charlie,
Clifford, I'm referring to you. Abudu,
you didn't ask the lecturer when he was around. You're not
I'm not
asking me.
asking. As you asking me, I'm not asking. Because this thing that Christian, you are there. You are looking at me. This thing that we are seeing this way.
At you. We are going to write.
You see, the thing is that if we were maybe focusing on a particular programming language, that one there may be practical sections. But if we are not using any programming language, then I think this is just the introduction. Where maybe in our subsequent semesters we will go into any particular programming language.
Fine, I know that, but I'm asking that in terms of this thing that they are calculating inside. Are we writing on paper or we are typing?
You are just doing it on your paper. It's not any computer. Because if it is going to be on computer, you will have to use a programming language. And which one have you been taught?
I see this thing mechanism to you computing one again.
Michael, what do you want to say?
You see, the thing is, in every programming language, we have what we call the syntax, the rules governing how you use words and then symbols and statements, how you write the sentences. So if we are not taught any particular programming language, then which syntax are we going to use to apply these things that they are teaching us?
I understand. This one is pseudo code.
One is just introducing us to the basics of programming, so that when we are not going into any programming language, it will be easier for us.
But those with the materials can check for us. Maybe in the next unit, we will be specifying.
No, you know the first cohort, for instance, they just started with them. They started C++ with them. But I think the lecturer made mention that they started with C++. But in this course, we are not doing that. So it means maybe we may do that one in a different semester.
Oh, okay.
That is what I am thinking. So this one is just to introduce us to the basics of programming in general.
Maybe due to their experiences with them, they are trying to change certain things.
Maybe to introduce us to the basics of programming in general. Then later we move into the language.
Yeah, I think so.
So the exams, how is it going to be? Is it going to be practical? Like the examples you was giving out?
Yeah, but that one is true. They can give you a mathematical expression and ask you to write it in a programming language listing. In a form that you have to write for the machine to understand.
Yeah, and also
One laptop.
You are not going to write on any laptop, bro.
It's going to be on paper.
Yes.
It's going to be on paper. But just that some of the things that they will ask you to write it in a flowchart manner, like how you would have solved that problem.
I think we'll be dealing with flowchart in algorithms.
Here too is there.
Okay. Oh, okay.
The algorithm, even this in this slide, there's an algorithm.
Yeah, you know they go hand in hand. You can't write a program without an algorithm.
Yes, yeah, the program and then the algorithm, they are the same thing. And the data
algorithm is something new. Hey.
When Dr. Famo was teaching math, people were complaining. Now you are seeing the math here. We shall see.
Come again.
So when Dr. Famo was teaching math and we are complaining, we will see it here. We are now coming to see something.
Frank, I'm on fire. That matter, but I just it. It be like drawing. You draw.
But if they are carrying on programming, then next semester, I think it's going to be C++, introduction to C++.
Yeah, I think
Those
that's
who
they normally say that's the industry standard language.
Yeah, those who just completed they did C++, and then software application development on top. Yeah, C++ different than application development, then web technologies using JavaScript, HTML, and code.
So you see, first cohort like this, web technology was part of the first semester courses, but they made changes.
Maybe they saw that there's a mistake.
Yeah,
because you need to get some prerequisite skills before before you delve into programming itself. That's why they are not.
Also, no course is easy nor difficult. You just have to put in your best and you make it.
It's not difficult. Look at this programming. The chapter 1, I thought it was something small. But when you look at the content, it's not easy. Even the course is voluminous. Look at the algorithm. You see it to be small, but when you pick one, you learn type, you not enter. Yeah. Yeah, good.
Is tomorrow morning's class coming on? No.
Oh,
guys, are we having the algebra class in the morning as
Hello.